Babies, how we doing? Welcome to our second video lesson for Chapter 7. Today we are going to introduce and talk about the properties of parallelograms, which are going to be a special type of quadrilateral. So first two definitions right off the bat. In this chapter we are going to be focusing on different special types of quadrilateral. So a quadrilateral is just simply any four-sided shape. Okay, now in this section, we're going to focus primarily on what are called parallelograms. So a parallelogram is a special type of quadrilateral. Parallelogram is, keyword within that is the word parallel, but it is a four-sided shape or quadrilateral where you have the opposite sides are going to be parallel to each other. So you'll see here kind of the markings on this diagram. Those arrows are showing that they are parallel. So PQ is going to be parallel to SR, and then QR is going to be parallel to PS. So that's why it's called a parallelogram, because the opposite sides are going to be parallel. So our goal for today is we're going to look at different properties of parallelograms to include relationships between the sides and the angles. First example here we're going to look at is how do we know if something is a parallelogram. So again, the word parallelogram means that the opposite sides are going to be parallel to each other. So in this example here, I give you 4 points that we're going to plot to make a quadrilateral. So you have L, M, N, and O. So if we plot those 4 points, we will get a quadrilateral that looks like this. So our goal is to try and prove that this is a parallelogram. So a parallelogram means that opposite sides are parallel to each other. So the opposite sides that we are going to look at are going to be L and O, and we're going to compare that to the opposite side, MN, and then we're going to look at LM, which is the longer side on top, and compare that to the opposite side of ON. Now, to understand if they are parallel, okay, so parallel is going to be the key thing. Anytime two sides are parallel, two lines in general are parallel, that means they are going to have the same slope. Okay, so what we're going to do is we're going to look at on this the rise and the run of each line. So starting with L to O, if I start here in the bottom at O, I would go up 4 and over 1. So I know that that segment right there would have a slope of 4 over 1. M to N, same thing. I'm going to start at the bottom point here just to stay consistent at the bottom. I would go up 4 over 1. So I know that M to N would have a slope of 4 over 1. So since they have the same slope, I know that those two are parallel. What I now have to check is the longer sides, L to M. So here L to M goes right 6 and does not go up 0 at all. So this would be a slope of 0 over 6. And then if I check O to N, same thing, 0 over 6 doesn't go up. So again, those would have the same slope. So because those two slopes, the opposite sides have the same slope, that means they're going to be parallel. So I know right away that this, yes, is a parallelogram. All right, we're going to do the same thing here. So now you have STUV. So we're going to plot those 4 points, to create our quadrilateral. Now our goal is to check to see, is this going to be a parallelogram? So we have to compare opposite sides again. So to help you guys out, opposite sides I would have is S to T, compare that to U to V, and then we're going to look at T to U, and we're going to compare that to V to S. So just kind of mark that on here. I would have the two shorter segments, and then I would have the longer segments. And again, I know I'm showing those marks of congruency, but I'm going to try and show that they are parallel. So what we have to do again is look at the slope. So comparing the slope here, I have for S to T would go up 2 over 3. U to V, I technically went from V to U. I went up 2 over 3 again. So that one ends up working out just like we want. And then for the next segment, T to U, it goes down to right 5. And then from V to S, again, I technically went from S to V. It also goes down to right 5. So that works out too. So again, parallelogram means that the opposite sides are going to be parallel to each other. All right, next example we're going to do is see if we can find the fourth coordinate, given that I know 3 of them. So this is going to be using our knowledge of a parallelogram. So you're given 3 vertices, W, X, and Z, and our goal is to find out where Y would be. So let me plot these 3 points. All right, so I should have these 3 points, X, W, and Z. Now my goal is to find the coordinates of Y. So just based on a parallelogram, I know that in order to make a four-sided shape, Y is going to have to be somewhere in this region right here. Okay, so what I'm going to do is I'm going to apply the idea of things being parallel and having the same slope. So I have my options. I have essentially two sides that I'm going to have to create. I'm going to have to create a side off of x and a side off of z. What I know is that it has to be parallel to one of the opposite sides. So I'm going to start from point Z, and I'm going to compare from point C, I'm going to compare that to the side that will be across from it, x to w. So if I were to start, let's say, from w, in order to get to x, I would need to go up 5 points and left 2. So from Z, I'm going to follow the same pattern. I'm going to go up 5 and left 2, and it would put me right here. So up 5 again, left 2 would go right there. Okay. Now, if I just connect this side here and call this, say, point Y, what I want to do is then also check this other side. So here again, I plotted point Y. So again, I know that this slope is going to be the same as that one, so they're parallel. But if I just check this side XY first, I know that W to Z, it goes down 1 and then right 5. So if I go from X, I would go down 1 and then right 5 again. So I know that that would be where point Y would need to be. So the coordinates of Y are end up going to have to be at 2, 1. So here's the idea of using the fact that parallelogram has opposite sides that are parallel to find the missing coordinate. Okay, I want you guys to try example 2 here, 2B on your own. So same thing we just did. I have quadrilateral A, B, C, and D, and I want you to find point D such that you are going to make a parallelogram. So go ahead, pause the video, give this one a shot on your own. All right, so D would be at a point of 0, 1. Again, looking at the slopes, I started here, compared these two sides, so I know that C to B had a slope of 3 over 2, up 3, right 2. A to B, I went down 2, right 3. So that means I had to track the same slope. So notice here, down 2, right 3 matches with the side across. And then here, up 3 over 2 matches with the side across. So parallelogram will always have opposite sides being parallel, which means they have the same slope. All right, so now what are some special properties of parallelograms? Parallelograms, again, have opposite sides that are parallel to each other. So because they are parallel, we have two things that end up being very important about parallelograms. And again, it's all based on them being parallel. So one thing is actually a property of parallel lines, that anytime two lines are parallel, that the distance between them is always the same. Otherwise, they would eventually intersect. So we call this, when we have a parallelogram, the opposite sides theorem. That the opposite sides within a parallelogram are always going to be congruent to each other. Okay? Now this applies to the opposite sides. Again, opposite means the sides that are across from each other. So think that is the word opposite. Now, this also gets into some stuff with the angles too, that it's also true, and this is actually properties of parallel lines. You might remember like the alternate interior angle theorem and alternate exterior angle and all that good stuff. It's kind of applying that stuff here, that also within a parallelogram that the opposite angles end up being congruent to each other. Again, opposite meaning across from. So this is just a special property of parallel lines that we can then apply to parallelograms. So what our goal is, we're going to use that idea of opposite sides and opposite angles being equal to each other to try and solve for unknowns. So example A and B here, we're going to use both properties at the same time. So in example A, you'll notice that I give you guys here the quadrilateral or parallelogram, A, B, C, and D. You are given x plus 4 on top, which is the length of A to B, and we are going to compare that to the side across from it, D to C. And now what we know, that in a parallelogram, opposite sides are always equal. I know that A to B, which is x plus 4, has to equal C to D, which is 12. So my goal is to solve for x based off of this. So if I just simply subtract 4 to both sides, I would get x is equal to 8. And again, if I were to plug in this, 8 plus 4, again, that would give me 12, showing that they are the same. Same thing is true now with the angles. You'll notice you're given y and 65 degrees. So since these are opposite of each other, I know that y has to equal 65 degrees. No solving there, but knowing x and y, again, using that opposite angles and opposite sides theorem of parallelograms. All right, what I want you guys to do is try example B on your own. Okay, so you have the side JK, compare that to the side across from, and angle J, comparing that to angle L, using the opposite sides and opposite angles theorem. So go ahead, pause video, try this one on your own. All right, so solving this, what you should get is y equals 15 and x equals 25. Again, I set the two sides 18 and y plus 3 equal to each other, solving for y. and then I set 2x equals 50. That's with the angles. Solving for x, I got 25. And notice when I plug these in, if I plugged 15 in where y goes, 15 plus 3 gives me 18. And here 2x, I plugged in 25. 2 times 25 gives me 50, which again is showing that opposite angles and opposite sides are always going to be congruent to each other. All right, a couple more examples. These are just going to be a little bit more involved there, folks, okay? So here we have my parallelogram PQRS. We're going to use the opposite sides and opposite angles theorem. The only difference here is you'll notice that in this first diagram, you are given x plus 9 for PQ and 2x minus 1. So using opposite sides, we know that those two are going to be equal. But notice here we have y for P to S and x plus 7 for QR. So we're going to have to solve for x and y. The only difference here is that when solving for y, you'll notice that y is across from x plus 7. So I cannot know y unless I know x, right? Whatever x is plus 7 would give me y. So that means I'm going to have to think about how to set this up first. So I'm actually going to use the x plus 9 equals 2x minus 1. Again, those are opposite sides to each other, so I know they're congruent or they're equal. So I'm going to try and solve for x. Notice here I got x on both sides of this equation. All right, so to solve, what I got to do first is gather my x's. So I'm going to start by subtracting x on both sides. That's going to cancel here, leave me with 9. And then remember, there's a 1 in front, so 2 minus 1 would give me 1x, and then minus 1. So here I would just have to add 1 to both sides, cancel out there. And what I would get is that 10 equals x. And again, I don't have to worry about that 1 in front, but I know that x is 10. So if I were to plug x is 10 into all of these things where I see x, I have 2 times 10 minus 1, which would give me 19. I have 10 plus 9, which would give me 19. So notice that works out. And now if I plug it into this other side, 10 plus 7 gives me 17. Whoopsie daisies, 17 there. Okay, so then if I want to solve for y, what I'm going to do is take y and set it equal to the x plus 7. But now knowing that x is 10, I know that y is going to equal 17. So I don't really have to solve anything there. I know right away y is 17. So by using the idea of opposite sides being equal, I can then solve for these unknown variables. All right, why don't you guys give number D a shot? Get it, number D. Now, number D, we're using the angles. So again, you have opposite angles being congruent. So I have angle A and angle C. You also have angle D and angle B. So give this a shot, pause the video, see if you can solve this one on your own. All right, a little bit more complicated here, but the x's, with A and C is set equal to each other. I have 3x minus 32 equals 2x. Solving for x, again, I kind of subtract the 3x here and then divided by the negative 1, you get x is 32. Plugging it back in, get 64 degrees for C, 64 degrees for A, showing opposite angles are equal. Same thing for angle B and D. Angle B is 4y, angle D is y plus 87. Subtracting the y, getting 3y equals 87, getting y by itself 29. For both angles, I get 116 degrees. So again, opposite angles are congruent. All right, last two things we're going to talk about here is what's called the consecutive angle theorem, and then we're going to look at diagonals of a parallelogram. So what we just talked about is that opposite angles in a parallelogram are always equal. So, for example, angle P and angle R are going to be equal to each other. Here, angle Q and angle S are going to be equal to each other. The thing that we got to remember back from section 1 is that if this is a four-sided shape, that means that all four angles, x plus y plus x plus y, should add up to 360 degrees, okay? So what ends up happening is that if I look at what are called consecutive angles are any two angles that are next to each other, not across from, but next to. So think of, for example, P to Q, or I could do even Q to R, or R to S, or P to S, whatever it might be. Just notice the color, I have red and blue there. So what we are going to say is that anytime we have consecutive angles, they are always going to add up to 180 degrees. If I were to show you kind of the mathy way to do that, is that since I have two x's, I could say 2x. Added with that, the two y's, when I add those things together, I should get 360 degrees. Now, if I divide everything by 2, what ends up happening is the 2's cancel out, and it says here that x plus y should equal 360 divided by 2 is 180 degrees. So this is what the consecutive angles theorem states, that angles next to each other in a parallelogram will always add up to 180 degrees. Okay, and the last one, we have the diagonals theorem. So diagonals in a parallelogram are always going to bisect each other. Again, the word bisect, if you remember back from the previous chapter, bisect means to, whoopsie daisies, means to cut in half. Okay, now the word diagonals, again, a diagonal is going to be a line that connects the opposite vertices of my parallelogram. So notice Q to S, the blue line, that is called a diagonal. And P to R, that is called a diagonal. And notice they intersect at that point M. That point M is the halfway point between Q to S and P to R. So these two things are going to cut each other in half. So our goal is we're going to use these consecutive angles theorem and some of the other properties we talked about, like diagonals, to try and solve for unknowns. So this first diagram, my goal is to solve for the missing angles. So notice you are given one of the angles. Now here's the nice thing about this. Normally, we would need like we did in section 1, we would need more angles to try and solve this. But here's what I know. If this is a parallelogram, we already know that opposite angles are congruent. So if I know angle E, for example, then I automatically know angle G. Angle G would be 60 degrees. Okay? Now my goal then is to solve for angle H as well as angle F. Okay, now here's what I got to know is that angle H and F across from each other are going to be equal, but they are not the same measure as G and E. But here's what I do know. I know that 60 degrees, which is angle E, plus one of those red angles, which I don't know, should add up to 180 degrees. So if I just take away 60 from 180 degrees, I will know the measure of that unknown angle. So angle H or angle F should be equal to 120 degrees. Okay? Now, the nice thing about this is that if I were to add up all four angles, 60 plus 120 plus 120, well, guess what I get? I would get 360 degrees, which is what all angles should add up to. So by knowing one angle and using our ideas of parallelograms, we should be able to find all the other angles. All right, next example we're going to look at is using diagonals theorem. So what we said is that diagonals in a parallelogram will always bisect each other. So you are given the length here of F to N as well as N to D. So notice that is along a diagonal. So here the point N is going to be the middle of that diagonal. So it is being cut in half by the other diagonal C to E. So cut in half means that this chunk right here, 5x minus 8 and 3x, those are going to be equal to each other. So just like previous problems, if I set those two things equal to each other, solving this equation, I should be able to find out what x is. Okay, I'm going to solve this one just slightly different just so you guys can see various ways to solve. But here I'm going to subtract the 3x. But when subtracting the 3x, I get rid of everything. So I'm going to need to add the 8 to this side as well, or to the opposite side to keep things consistent. So what I would get is 2x equals 8. And therefore, if I divide both sides by 2, I would get x equals 4. And by knowing now that x is 4, I can take that and plug it in. 5 times 4 minus 8, which would give me 12, and then 3 times 4, which would also give me 12. So notice that those two diagonals, or those two chunks of that one diagonal, are going to be equal, again, because they bisect each other. All right, I want you guys to try one on your own. Last example, I know it says B, but that meant C, but I want you to try and figure out what x is and the length of those sides. Here's your diagonal. You have M all the way to P, and notice this point right here is that halfway point being cut in half by Q to N. So go ahead, pause the video, try this one on your own. All right, so solving here, you should get x equals 2. Plugging 2 into both those pieces, you would get 4 and 4 apiece. Again, so what we looked at today, I know there's a lot of meat and potatoes involved here, but looked at the special properties of parallelograms, looked at the opposite sides and opposite angles theorem, again, that those are the same, and then the consecutive angles as well as the diagonals theorem, where consecutive angles add up to 180 and diagonals bisect each other. All right, so if you got any questions, I know there's a lot in here, so if you need to go back and rewatch something, do that. Otherwise, if you got any questions, jot those things down, post them on Google Classroom. We'll see you guys on the interweb. Okay, peace out. Bye now.